So, let's start. Let's start by reviewing some special triangles that you learned about last year.
Oh my God.
I knew it. There was something familiar about this.
30, 60, 90s?
Yep.
Oh, yes!
Now,
Oh my God.
you guys don't like. Do you guys mind if I use A? Let's use A. So if for a 45, you can use whatever letter you want. If a 45, 45, 90 triangle has one of the legs A, what's this leg?
A.
And what's the hypotenuse?
2.
Very good. Okay, so just hold that thought. Now let's do 30, 60, 90.
Yes.
30.
Oh,
We start with short leg. We'll call that A. And I always remember 1, 2, root 3 is the numbers that need to get filled in there. This is 1. Where's 2A? And then where's the root 3? The other leg. Okay? So these are things you learned about last year.
yes.
Now, let's go ahead and write out sine 45, cosine 45, and tangent 45. Okay, so pick whichever 45-degree angle you like. In a triangle, that's a right triangle. To find sine, you do. So let's say I'm looking at this one. You do what over what? Opposite over hypotenuse. So A over A root 2, which proves that it doesn't matter what length of the sides we have, if it's 45, 45, 90, you're going to get 1 over root 2, which is root 2 over 2. Cosine 45 is adjacent over hypotenuse. It's the same calculation, right? So I'm just going to write root 2 over 2. And now for tangent 45, so if I'm looking at this one, tangent is opposite over adjacent. A over A is 1. Okay? So sine of 45 equals root 2 over 2. Cosine 45 equals root 2 over 2. Tangent 45 equals 1. Okay? We're going to do that again for the 30s and the 60s. In fact, why don't you guys take a minute or two and figure them out on your own? All three of them for both angles. So I'm looking for sine 30. So yeah, there's 6 more you got to figure out. Cosine 30. Tangent 30. And then 60. So all we're looking at is 45s, 30s, and 60s. Yeah, because 90 has some of those like undefined, like tangents wouldn't work. Yeah. Question? No, it is not. Clean up your answers as much as you can. One, two, three, 4. 1. Yes. Krista,
Okay.
do you have 30s going?
I think.
What do you have? Sine 30 is
I put A over 2A.
So what's a divided by 2a if you... Very good. Cosine 30, what did you get?
I got 3.
Very good. And what was tangent 30? Very good.
So,
Row 1. 2. Kendall.
I'm not saying.
Because he's 1. What'd you get for sine 60?
For sine 60?
Yep.
Square root of 3 over 2.
Okay.
Then it's 1 over 2.
Yep.
And then it's 1 over square root of 2.
isn't it
Yeah.
3?
Tangent 60.
Oh, my bad. I was looking at the wrong one.
It's
Square root of 3.
Square root of 3. Okay. Are there any questions? Any questions whatsoever on how we got these values? Okay. Now, do I recommend that you just know these? Yes. Is it the end of the world if you don't? Not really, because the most important part is what we're going to do now. Okay? So what I recommend doing is actually, before I draw stuff on the unit circle, I just want to illustrate where this is going to go. Okay? So let's say we have a unit circle.
Wait, should we draw this?
You don't need to. I just want you to understand where I'm getting my calculations from, and then you're going to see real quickly how we're going to fill things in. Let's say I rotate 30 degrees. Okay? And now we're on the unit circle. You guys see that there's a right triangle here, right?
So that's going to be 90.
So it's a 30, 60, 90 triangle. And you can label that as 1 if you like. So then, if we work backwards, the short leg would be half, and then this one would be root 3 over 2. Right? Because you take short leg and multiply it by root 3. Okay? So, what does that tell us about these coordinates here? What's x? Root 3 over 2. And what's y? Not a coincidence that the cosine of 30, which should be the x-coordinate at 30 degrees, matches up, and that the y-coordinate is a half, which is sine. Okay? So do you guys see where this is going?
Yeah.
I can do this all day and do 45, 60, and label everything all the way around the unit circle. Okay, so now here where this is going to go. So let's go right here. And we'll start filling this in. And now what I recommend you do, if you have colors or different ways to make things look different, 3 of them, you should do that.
3?
Yeah. Now, the unit circle is the one that's in bold out here, right?
Oh.
From 0, we already labeled this yesterday, so let me just catch up. This was 0 degrees, 0 radians, and the coordinates here were 1, 0. We also said that 360 degrees, which is 2 pi, also has the same location, right? Now, from 0 to here is how big? Half of pi, which was 90, right? We labeled that, so let me do that. 90 degrees is the same as pi over 2, and the coordinates here were 0, 1. Okay, so now let me fill in between. This is what we talked about yesterday. There are 1, 2, 3, 4, 5. There are 6 little sections to get from 0 to 90. So how much is each section worth in degrees? 15. We didn't talk about 15, did we? We talked about 30. So we're going to skip the first one and go to 30 right here.
Should we draw that one?
Yep. And then I would use a different color. 45 would be which one? The next one over. It's just 15 more degrees. And then the next one, 15 degrees more, is 60 right here. All right. Now, we already did the 30 one, right? So we have 30 degrees. And now, if you don't know the radians, by the way, you're going to memorize the radians for all this stuff too. 30 degrees.
Should we write that in a different color?
It's up to you.
Oh my god.
Pi over 6. Very good. Hopefully soon, rather than later. Maybe tomorrow even. You're going to come in tomorrow knowing pi over 6 is 30. 5 pi over 6 is 150. 225 is 5 pi over 4. And things like that. Okay? What were the coordinates? We figured those out already. It was root 3 over 2, 1/2. So the goal here, before we do our couple of examples for this section, we're going to label this unit circle going all the way around with all the right angles, 30, 45, 60, 90. Let's do these three first together. So the next one is 45, which is how many radians? Pi over 4. Very good. And if you need to look back, what are the coordinates going to be? Root 2 over 2, because the cosine was root 2 over 2, right? Wasn't the sine the same? So the coordinates for x and y are the same. Justin? Another one? I do not. Do you have yours at home at least? Okay. Worst case scenario, Justin, Google unit circle. The first thing that pops up is a copy of this. Okay. The next angle is going to be 60 degrees. How many radians? Pi over 3. Very good. What happened to the cosines and sines when we did all those? They just reversed, right? So now x is going to be 1/2. Y is root 3 over 2. Now here's the cool part about the unit circle. This is all you need to know to figure everything else out.
Really? Oh,
Because look, root 3, the only options that we're going to have so far are zeros, ones, what else? 1/2s, and root 3 over 2s. Those are the only options, and root 2 over 2. So we have 5 options there. Okay? Now, the easiest way to label the unit circle, and I did the colors for a reason, okay? The reason that this was 30 and it has these coordinates is because we drew a little right triangle in here. You guys see what I'm talking about? That had a 30, 60, 90 pattern, right? If I go over to the second quadrant and do the same thing, so that this angle over here is 30, you guys see how that's going to match up, right? So that we're going to color code all these angles. So the ones closest to the x-axis are all going to be related to this ordered pair. Okay? The middle one is always going to be related to the 45. And the one furthest away from x is always going to be related to 60. Do you guys see what I'm talking about here with these colors? Okay. So in the third quadrant, let's see, let me just...
Wait, there's only 5 lines.
It's the middle 3 that we're looking at.
Okay.
Because we skipped 15, make it 30, 45, 60. We don't have a 75. We have 90. We're not going to have a 105 yet. Okay? But 120, so actually let's label that. This is going to be 120. What's the next angle? 135. And then this next one? 150. Do you guys see how I'm getting those? Okay? Here's what I'd like for you to do. let me set up the color coding. I'm going to give you a couple minutes on your own to see if you can fill everything in. So if I'm going in a third quadrant, I'm going to skip the 15-degree angle. The next one should be what color? Blue. Very good. For me, anyway. For you, I don't know. What should the next color be? Here, right here.
Great.
And then?
Whatever.
The other one. Magenta.
Sure. Or pink.
All right. And now if I go to the fourth quadrant, we're going to skip the 15, go 30 more. What color should this be right here? You see how these all match? In fact, you can just make them straight if you want. Straight lines to get all these. Next one is green.
They're on, what angle are they on with each other?
We're going to figure it out. And then blue for the last one. Okay. Huh?
What are those colors?
Yeah, we're going to get to why we're doing this. My short answer is you have no prayer in passing pre-calc or calculus if you don't know this. That's my short answer.
What's the long answer?
The long answer is because it's life. Trig is everywhere.
It's always like this.
Yes. Yeah.
Language is everywhere too.
Yeah.
People make use of it. Wanted to get philosophical.
Now, do you see why I color-coded these rays?
Yes.
Look at the blue 30-degree mark. What were the coordinates? Coordinates were root 3 over 2, 1/2. All the other blue ones are going to have the same order. Root 3 over 2, 1/2. The only thing you have to adjust is negatives and positives depending on what quadrant it's in. Does that make sense? Okay. Do you guys know what these angles are over here? Let's do all the degrees first. Okay. This is 180. This is 210. 225. And then 240. 15 and 15 more make 270. Go 30. We get 300. 315. And then 330. Okay, so those are all the degree measures for the unit circle. Now, I'm going to show you the way I remember the radians. Okay, there's a lot of different techniques out there. Okay, there's a couple things that I always like. All the angles that are in the same position, do you see what I mean by low, 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 are going to have pi over 6 in it somehow. Okay? Somehow, these blue angles are all going to have 6s. Okay? So this is going to be something over 6. This one's going to be something over 4. And this one's going to be something over 3. 6, 4, 3. 3, 4. It always goes that way. What about over here? This is the one that's closest to x, so that'll be over 6. This one will be over 4. And this one will be over 3. This one is going to be over 3, 4, 6. Okay? Now, how do we quickly figure out the radians? Let's fill in the big ones. 180, what is that? That's pi, right? Coordinates were -1, 0. The easiest way to do these is to realize that all of these are almost pi, but not exactly pi. So, for example, 6, how would I make a denominator of 6 equal pi? It'd have to be 6 pi over 6 to be equal to pi. Does that make sense? Think of it as 6 pi over 6, but we're back 1. So this will be 5 pi over 6. Do you guys see how we're doing that? This will be 3 pi. This will be 2 pi. It's always 1 less. 1 less than the denominator.
So next one's 8 pi over 6.
Keep remembering pi is 1/8.
What's that?
Next one is 8 pi over 6.
Not 8. So here we're 1 less than pi.
More, so 7.
Here will be 1 more than pi. So this will be 7 pi over 6. And 5 pi over 4. And 4 pi over 3.
Makes sense.
270 is one of the big ones we should already know. That's 3 pi over 2. Okay? Now, the second quadrant, I'm not going to think about pi's anymore. Am I closer to pi or am I closer to 2 pi? 2 pi. So think about doubling, right?
It's gonna be 11.
Very good. 11 pi over 6. It's going to be 1 less than double, right?
So 7.
7 pi over 4.
5 pi.
5 pi over 3. Very good. Are there any questions on how we're getting the radians? Justin.
Isn't it a coincidence that if you follow the color code up, it's 2 pi, and then down there it's twice plus 1? So if you follow like the purple line,
From here to here?
yeah,
Is it a coincidence that it's double plus 1?
yeah.
No, it's not. Yes?
So in the fourth quadrant, it's 1 less than double.
1 less than double. Okay? If you guys have some good fraction knowledge, like common denominators and stuff, that's probably the easiest way to do it. The very least, you guys have to memorize this. Pi over 6, pi over 4, pi over 3, or 30, 45, 60. Make sure you know these coordinates, and then the rest you can fill in the same way we just did now. Okay? Do you guys remember how we got these? Second quadrant, the numerator was 1 less than the denominator, because we're not exactly at pi. We're just 1 away. 1 pi over 6 away, 1 pi over 4 away, and then 1 pi over 3 away. Does that make sense?
You're talking about
Yes.
Can't you just think about it because if we found on the first quadrant where it was like over 3, 4, 6,
Yep.
they all just like correspond.
Yes. Yes. But just make sure that you remember the numerator part. What's that? Yeah. I just want to make sure everybody understands where we got all these degrees and radians from.
How do you get the so that
Third quadrant, numerator is always what?
one more?
1 more than the denominator is the numerator. 270 is 3 pi over 2. And then second quadrant, we would double and take away 1. Okay? Now the coordinates you guys can fill in on your own. I'll give you a minute or two to do that. They're all going to match. Anything with a 3 on the bottom is going to have a half and root 3 over 2 for the x and y. The only difference is over here at 2 pi over 3, what are the coordinates going to be? Negative a half and root 3 over 2. Okay? Do you guys see how I'm doing this? Let's say I go to the fourth quadrant, and I'm looking at 7 pi over 4. What x's and y's should this have? It should match the pi over 4 from the first quadrant, root 2 over 2, root 2 over 2, but now in the fourth quadrant, what's negative? The y coordinate, right? Do you guys see how that works?
Is that what we said?
No? Where are you confused, Patrick? All you do is just adjust the positives and negatives. This is why radians are awesome. No, seriously. Because if you look at 135 degrees, you may not know right away that the ordered pair is going to be negative root 2 over 2, root 2 over 2. But if you know 135 is 3 pi over 4, you know that pi over 4 is root 2 over 2, root 2 over 2, and then you just adjust accordingly. Okay? Where are you confused, Kevin?
What do you do? Like, I can see 45 is root 2 over 2, root 2 over 2, and then 315 is root 2 over 2 with that negative.
Yeah.
Why?
Because they're both 45 degrees away from the x-axis, so it's going to be the same right triangle.
Can we treat this like a graph, right? Or x is negative, making a y negative?
Yeah. Also, I mean, literally, think about this as a graph. If we're looking at 45 degrees, you guys, we agree that the x-coordinate has to be root 2 over 2, right? Go down to the fourth quadrant. What's the only thing that has the same x-coordinate? It's going to be right here. It's got to be the same x-coordinate, right? Yes?
I'm confused where you said, like, in quadrant, what, 4?
Yep.
You said to look at it, like, as 2 pi.
Yeah.
What does that have to do with?
Because in quadrant 4, we're almost all the way back to 2 pi, but we're not quite there yet.
Does that affect any of?
Well, because if we're thinking about everything in terms of pi over 6, think about what pi over 6 needs to be in order to be 2 pi. Common denominator, it'd have to be 12 pi over 6, but we're not quite there yet.
Okay.
We're 1 unit away from that, so subtract 1 to make it 11.
Okay. Okay.
Yes?
So if the point you're looking at is completely diagonal, then both are flipped.
Yes. Everybody good? Other questions?
Oh, are we not doing all the coordinates?
Yeah, you should have done that.
Dude. Oh, whoops.
Use some common sense. The graph. Here, I'll do one with you, Kev. 5 pi over 6. What x's and y's should that have? Root 3 over 2 and 1/2. See how easy that is? Now, if we're in the second quadrant,
Why?
there you go. Done.
How do you know that?
Because it's at the same position, just on the other side.
Okay.
So does that mean 2 pi with the negative of 2 over 2, negative of 2 over 2?
Say that again?
225 degrees.
Yeah?
Negative of 2 over 2, and then negative of 2 over 2.
Yes, it's that easy. Everybody good? Justin, you good?
How are we going to find x and y of 345?
345? We're not going to do 345. You could do it with some other formulas that we'll talk about in a couple of units. Right now, everything that we're going to do is going to be based off of these angles. 30, 45, 60, zeros, 90s, those are all things that we can handle. 15 degrees we'll get to eventually, but not yet. Okay?
Wait, on this we're going to do 15?
Not on this pat. No, this is like a couple units away. Okay? Yeah.
Wow.
Are we good? Everybody got everything labeled?
No. Wait, Mr. G, so
I mean, here, I'll go ahead and label it. Negative root 2 over 2, root 2 over 2. This is going to be negative root 3 over 2, negative 1/2, negative 1/2, negative root 3 over 2, 0, negative 1, negative 1/2, nope, positive 1/2. Root 3 over 2 is negative. That's good, that's good. And then here I just need root 3 over 2, negative 1/2. Okay, look. Here's the key. If you can memorize this, the right quadrant, the first quadrant, that's all you need. Because you can piece everything else together, and you should be able to do it quickly. Okay? So for instance, later on it's going to be, tell me what the sine of 7 pi over 6 is. So your thought process is going to be 7 pi over 6. Well, that's pi over 6's coordinates. Pi over 6's coordinates, so you're going to know it's root 3 over 2, 1/2. And then you're going to have to figure out 7 pi over 6 is over here, and then now you know the answer. It's just the y coordinate over here.
Would we be able to use this?
Absolutely not. No, this needs to be memorized. The whole thing, yeah. Are you kidding me? When you get to later trig stuff and in calculus, if this stuff takes you like 5 minutes to figure out an answer, you have no way that you're going to finish any test. AP exam, nuh-uh.
So trig is pretty big in calculus.
Trig is huge. Just ask any calculus student if you should know trig, and they're going to go, uh-huh. Okay? Yes. We mush it together. Yeah, right? Trig is fun. Now, here's how it works, okay? Well, I didn't do much. It's just everybody was confused. How much have we written down? Not much.
That's a lot right here. Excuse me, Mr. G.
Okay, guys. Whine away. Let everyone in the whole world, let them know how you really feel.
Your statement's
31 minutes.
We're making a video?
Yeah.
Oh, Lord.
Wait,
Wow.
were you making a video this one time?
Yeah.
I'm famous.
How do you
And Saeed didn't.
Okay. So now here's how everything works, okay? Let's do an example. We want to find sine.
Say something what?
Actually, let's do all 6. All 6 trig functions for 2 pi over 3. Okay? So here's how it's going to work. First thing you do. First thing that you should do is locate it. And I always think about it in terms of quadrants. Is this going to be quadrant 1, 2, or 3, or 4?
2.
Wait, what is it? All 6 what?
All 6 trig functions.
That's what.
Look at the numerator. Is this 1 less, 1 more? 1 less than what?
2 pi.
1 less than 3, so it's almost 2 pi, but not quite there yet. Okay? So we're in the second quadrant. We're in the second quadrant. Now in the second quadrant, we know that x is negative, right? And y is going to be positive. So now all you have to do is look right here. It tells you where to look. Pi over 3. So once you have this memorized, you're going to know that it's not the first or second one, but it'll be the third one up, right? What are the coordinates for the third one up? Root.
1 over 2 squared.
Negative 1 over 2.
Uh-oh, which one is it?
No, it's negative 1/2. Negative 1/2.
The third one up is a half, root 3 over 2. So we're going to do negative 1/2, root 3 over 2. Do you guys see how we adjust this? Okay, and now we're good to go. All 6 of those trig functions, which, yes, you have to memorize those. So let's find them. Cosine is what coordinate?
Negative 1 over
That's x, so negative 1/2. Sine for this angle is, so that'll be root 3 over 2. Tangent theta is going to be y over x. It's a negative.
Negative 1/2. No,
Negative root 3 over 1.
Wait, what?
It's just negative. It's just negative root 3. Root 3 over 2 divided by negative 1/2 is the same as root 3 over 2 times the reciprocal, right? Which I didn't write. 2 over 1. Cancel them out, you get negative root 3. When you do this, the way I'd like to do this, if the denominators are the same, you guys, these are going to cancel out. So it's just like doing root 3 over negative 1. Does that make sense? Secant is reciprocal of cosine. So that's going to be negative 2. Cosecant is reciprocal of, very good, 2 root 3 over 3. It's just the reciprocal of the sine. So it's 2 over root 3, and then clean up the denominator.
Secant is corresponding to cosine,
Yes.
yeah?
And then cotangent, either look at the coordinates or do the reciprocal of your tangent value. So that'll be negative 1 over root 3 or negative root 3 over 3. Do you guys see how this is working now? Kevin?
How did
Serious math.
Stop it.
It's all for the games until we get something.
True. Root 3 over 2 times negative 1/2.
It's gonna be like, oh,
And it's
95 degrees. I'm like, oh,
Negative
oh my
2
God,
over 1. You're dividing by negative 1/2, which is the same as multiplying by the reciprocal. Okay. All right. One more, just for good measure. Let's say we wanted to find all 6 for theta equal to 315 degrees. Okay? Now, you may not know what angle we should be thinking about right away when it's in degrees. So here's how we do it. Is this closer to 180 or closer to 360? How far away is it from 360? So the reference angle that we should have in mind is 45 degrees. Do we know the coordinates
Yeah.
for 45 degrees?
Yeah.
What are they? That's the easy one.
Root 2 over 2.
Root 2 over 2, root 2 over 2, and yes, you guys are right. One of these is negative. Which one?
Negative
the
second
Y.
The y coordinate's negative.
Wait.
Everybody with me?
Because it's in the fourth quadrant.
Yep.
So it's not
Good enough.
So now can we find cosine and sine and all that? What's cosine?
X.
So root 2 over 2. Sine is,
Negative.
see how quick we can do this now once we get better? Tangent.
Negative 2 root 2 over.
Oh, don't overcomplicate it. These are the same number. Just one is negative, right? So it's negative 1. If you divide a number by itself, you just get 1, right? Secant theta is reciprocal of this guy right here. So flip this around. 2 over root 2 is the same as 2 root 2 over 2, which is just root 2. Eventually, you don't have to do this whole process. You're just going to know root 2 over 2 is the reciprocal is root 2. Cosecant. The cosecant is going to be the same, right? It's just going to be negative because it's the same coordinate, just negative. Cotangent was reciprocal of negative 1, which is still negative 1. So there you are. Those are all 6. Okay?